do. Okay, this is question 7 on your take-home exam. Now, we worked it out partly last time. We had confusion about what the answer should be, so I'm going to go ahead and finish it. And I'm going to show you how to check it as well. So we want a 40% antifreeze solution. So what does that mean? That means the 40% is going to go on the right-hand side in box 3. Because this is what we want. Okay, we want that. We want a 40% solution. Now, what are we going to start with? Okay, the car comes in. The car has 60 liters. This is what we've got right now. 60 liters of a 20% solution. So that goes there. Then we've got our pure. Pure is 100%. And what do we know? Well, whatever we add in, we also have to subtract off, right? And right now the car is full. They've been adding water, it's full. We want to end up with it also being full, and so at the end it's also going to have what? 60 in box 3. Now, how much is the pure? Do we know? No, it's unknown, so I use an X. Now, I can't just add in more because it'll overflow. So whatever I add in, I have to also subtract off. That way the X's do what? Cancel, and you've got 60 equals now what? 60. Okay. Now we're going to build our equation. So it would be 0.2 times 60 minus X. That's your first one. Those just go together. Plus 1x, or just an x, because that's your second one, 100%. That is going to equal 0.4 times 60. Distribute through. So if I distribute through, I've got 0.2 times 60. That is 12 minus 0.2x plus, now here's where you might make a mistake. This is 1x, right? So there's a 1 there. And 0.4 times 60, well, that is a 24. If there's a mistake, more than likely it will be right here. So those are going to go together. 1 minus 0.2, well, that's a 0.8x. I'm going to move the 12 over. So that has to be subtracted off. So now I've got 0.8x equals 12. And 12 divided by 0.8, that gives you then x equals 15. So it should come out to be an answer of 15. Now, how can we check? Okay, let's make sure that we know how to check these, because if you want to get the answer, make sure it's right, because this question will be on your final. How do we check it? Well, let's see what we've got. The first one, how much is in there? 60 minus x. So what is that? That's 60 minus 15, which is then what? 45. And that's 45 in this case. Was it milliliters? I should label this too. Yep, it is. Nope, it is in liters. So this is in liters, so I'll go ahead and label it. This is the answer. This is what I want. This is the answer. What we're doing here is we're just going to check. So I know that that first one is 45, right? So that's 45. And what percentage rate does that first one have in it? Okay, 20%. So 45 times 0.2, what does its pure come out to be? 45 times 0.2, that is 9. Now let's check the second one. How much is the second one? X, and X is 15, and it's pure, so it's 100%. So 15 times 1 is a 15. What about the other side? What is it? Okay, the other one is what? is 60 times 0.4, and that comes out to be 24, doesn't it? Now, how can we check to make sure it's right? 1 plus 2 should equal 3. Well, does it do that? 9 plus 15, does that equal 24? Yes, 24 equals 24, so we know that we did it correctly. Now, you don't have to check it, but if you want to, you can. Okay, make sure it makes sense. But that's how you would check it. You would add up the pures and make sure it all comes out to be the same. So is everyone okay with how that one is done? Because chances are you'll see one like this on your final. I got rid of 10 questions, and I think I kept this one on there if I remember right. Okay, so that takes care of that question. I wanted to do that one first, just so we would make sure we know how to work it out correctly. We'll go back now and get 4. And these are on the take-home final. We're going to look at question 4. Let's see what we've got. Now, I'm not going to completely work out question 4. I'm going to partly work it out for you. Now, there are 2 ways of doing question 4. They're about the same level of difficulty. You can either use the midpoint formula to find the center. Put it up here so we can see. To find the center. And then use the center with either one of these points to get the radius. Or you can take these 2 points, find that distance, and half it to get the radius. So I'm just going to use the distance formula. And you can use the midpoint formula first to get the distance, but I think it's easier just to use the distance formula completely. I think when I worked out the key, I found the center and then use that to get the answer. And that's okay too. But here's what we've got. We've got minus 2, 1, and we've got 4, 9. And these come from the diameter. Now, what we want is we want the radius. How does the radius relate to the diameter? Well, if we don't remember, the radius is equal to the diameter over 2. Does everyone remember that? Okay, so this is going to give us our diameter. We want the radius, so we're going to have to divide it by 2. Now, how do we find the diameter? Well, we find the diameter by using the distance formula. And what's our distance formula? Okay, the distance formula is this. D equals the square root of x1 minus x2, quantity squared, plus y1 minus y2, quantity squared. So there's our formula. I'm going to do one more step, maybe 2, and the rest of it for you to work out. So this is x1, y1, x2, y2. So that's what we're going to try and find. Now, what does this give you? This gives you the diameter, not the radius. So that's going to give us our diameter. Let's plug our values in. And we've got, and watch your signs. Where students make a mistake is with the signs. We've got, look at your ordered pairs here, minus 2, minus 4, quantity squared, because it's the x's. These two don't go together. It's these two on the ends. The x's go together, and the y's go together. So 1 minus 9, quantity squared. Okay, now we can work it out. And minus 2 minus 4, that makes it a minus 6, quantity squared. And then we've got 1 minus 9, that makes it a minus 8 quantity squared, doesn't it? All right, is everyone okay with that so far? I'm going to leave this for you to finish. So you can break it down. Now, what about my answer? This is the diameter. So how do we get the radius? To find the radius, divide by 2. So whatever you find, you're going to divide it out by 2. Let's see, did I make a mistake? Did I write down the wrong numbers? Oh. Yes. It'll come out. This will come out to be 36 and 64. That'll give you 100, which is 10, and then half of 10 is 5. So that's what I want. Okay, is everyone okay with how I got that, though? You need to finish it on your own. I'm not going to do it for you, but yes, you're right. It will be 5. Is everyone okay with that? Because you're going to see one like this on your exam. It's pretty simple, as long as you remember the steps and what to do. Question 5. Question 5, you have seen this before. Because question 5 was on your second exam. And I know we went over it quite a bit. This one's a commonly made mistake on this one, is that 10. So question 5. A building needs a ramp to make it handicap accessible by law. The ramp must run 10 inches horizontally for every 1 inch of rise. So it's a 10-to-1 ratio. The surface of the ramp is 51 inches long. How far above the ground is the inclined end of the ramp? Round to the nearest 1/10 of an inch. So let's draw our picture. So how long is this ramp? If we read it, the surface of this ramp is going to be what? 51. So 51 goes here. How tall is the ramp? Do we know? No, we do not know, so we use an X. How far is it across the bottom? We don't know that either, but what do we know about the height to, or the rise to the run? We know it's a 10-to-1 ratio, right? So what does that mean? That means if this one is X, then the run is going to be what? 10 times it, so that'll be 10x. So it's a 10-to-1 ratio. It might be a 5-to-1, might be an 8-to-1. But we have a right triangle. And how do we approach it from here? What method do we use to solve it from here? We have a right triangle, so that means we have to use the Pythagorean theorem. We've got A, B, and C. And so with the Pythagorean theorem, we know that a squared plus b squared equals what? C squared. So this is your A, this is your B, and this is your C. I'm going to set it up. I'm going to get you in the right direction, and you're going to have to finish it. So I'm going to do one more step. Let's build our equation. This is question 5. Yep, question 5 on that take-home final. I'm not going to work it out completely because you've got the practice one to look at as well. Okay, you always go back and look at the practice one. You've got the keys, how I worked it out, so you can see that. But I'm going to do one more step because we know we need to use this formula, which is a squared plus b squared equals c squared. So what do we have? We have 10x quantity squared. Here's where the mistake is. 10x quantity squared plus x squared equals 51 squared. Here's where the mistake is. A lot of times, students make the mistake of not distributing that square through. So we have to square the 10. So 10 squared is then 100x squared. We distribute it through. Plus x squared equals, and I'll go ahead and square the 51, which is 2601. You can finish it from here. What property would we use to finish it? Does anyone have any idea? Square root property. So how would we finish it? I'm going to talk you through it, but I'm not going to write it down. What would you do? You would combine the 100 and the x squared. That makes it 101. Divide, take the square root. Now, you get plus or minus, but can we have a negative answer? No. Right? So you're going to get two solutions. The negative one is not going to work because we are looking at a height. And then it wants both of them, doesn't it? It says, it doesn't want both. It says, how far above the ground is it inclined into the ramp? So you find that. That's going to be the x, and that's the height. Okay? And that's all you need to do. Finish it out. Use the square root property, and that's it. But you can finish it. I don't want to work it out completely because I don't want you to just copy things down. I want you to do these again. That's why I'm giving you this, is so you do well on your final. Sure. Yep. Yep. Okay. Do I need to? Is that enough, or you want me to go further? Okay. So next we'll look at question 14. Does that make sense now? Okay. Yep. I'll move this up a bit here. And we're going to look next at question 14. Now, I also picked 15. Well, you picked 15. Or I want to make sure we do 15 as well. But let's look at 14 first. These are exponentials. And this is chapter 4. And when we work with these exponentials, we need to make sure that we either have the same base or we have the same exponent. One of them has to be the same so we can find the other one. Over here? Yeah, that'll come out to be a 4 to the negative second power. And we'll talk about that here in just a moment. Okay, but this is the original equation. Now, we want to get these to have the same base. So, we want to have a common base. What do we know about 16? Let's look at our bases here. We've got a 4 and we've got a 16. Well, we know, first off, that 4 raised to what power makes it a 16? Second. And then we also have the negative exponent rule that says a to the negative n is the same thing as 1 over a to the n power. So we can flip it over. So we know that 4 squared is what? 16. Now, I can flip this over by rewriting it. So when I rewrite this, it's going to be 4 to the negative second power. Why is it 4 to the negative second power? Because I can flip this fraction over, right? And then we know that 4 squared is what? 16. Is everyone okay with that? Now, it might be maybe 5 and 125 on the other side. That would still come out to be a 5 to the negative second. Or it might be 125 down below, which would be 5 cubed. Okay, but whatever we have, we need to make sure we have the same base. Are the bases the same? Yes, they're both base 4. So that means that these have to be then what? The same. So what does my equation now look like? It looks like 7 plus 3x equals negative 2. And you can finish it from there. There's not much to these. Now, as you can tell, this is not a difficult question. It is designed to make sure that you know the concepts. All you need to remember is how to get a common base, and then the equation is very, very simple to solve. So as long as you can get that common base, then you won't have any trouble at all. And negative exponent rule says I can make that fraction a negative exponent. So I flip it over, and we know that 4 squared is 16. 15. And 15 is one of the most commonly missed questions. I've given different versions of this final over many, many years, and this is one of the most commonly missed one, is question 15. Just like the last one, we need to make sure that we have everything on both sides of common base. So we need to make sure that all of our bases are the same, common base here. Unlike the last one, though, I can't take 8 and raise it to a power and make it 32, can I? Now, that won't work. But what do we know about 8? And what do we know about 32? They're both even numbers, aren't they? So if they're both even numbers, then they're a power of 2 in some way or another. So let's think about what we know with 8. Well, 8 is 2 cubed, isn't it? We should know that. We know our cubes. So we know that 8 is 2 cubed. Well, what about 32? Can 32 be some number, or 2 raises some power? Yeah, it can be, right? What would that power be? What's going to go in the box here? Does anyone have an idea? 5. How did you get that? Well, let's see. We know 2 squared is what? 4. 2 cubed is 8. Doesn't work yet. 2 to the 4th power is 16. And what do we know about 2 to the 5th power? That's what we want. So that is then going to be a 5 there, isn't it? Now we can rewrite. So 32 is 2 to the 5th. So we'd write 2 with the power of 5 and we multiply it by whatever is left over. So make sure you use your parentheses there. We have to use parentheses. What about the other side? It's going to be 2 cubed, yep, times the 4x, okay, which is 12x, right? Yep, you just go one step ahead and that's fine. Are my bases the same? Yes, the bases are the same. So what does my equation now look like? It looks like 5 times x minus 1 equals 3 times 4x, and you can finish it from there. Is everyone okay with how I got the common base? Now, it might not be a 32 and an 8. It might be it might be a 16 and a 64, something like that. Well, not 64, but it might be a 128, okay? You're going to have to get a common base and work it out the same. Once the bases are the same, that forces the exponents to be the same, and look at how easy that is to solve. There's not much to it at all. Right? Well, it'll come out to be fraction. We can go ahead and finish it just to make sure. How would I finish this out? I would begin by distributing the 5 through, right? So make sure you watch your signs here. So that would be 5x minus 5. And what about the other side? 3 times 4 is a 12. So that's 12x there. And move it over. And now we've got 7x equals negative 5. And so you should know that x is now negative 5 sevenths. Okay? But do we see how it's all done? Because you're going to have one very, very similar to it on your final exam. I don't want you to miss that question. It's an easy question once you see all the steps and concepts. 24 I picked because 24 students make a mistake a lot of times with that 4. So 24. 24 is f of x equals 4x quantity squared, right? Now, with the parentheses, what am I going to do with the square? The square has to be distributed through. Okay, so if I distribute that through, what does that give you? 16x squared. I'm not going to graph it completely, but we're going to talk about it, and you can finish it. Now, what is the graph going to look like? Is it going to look like this? Is it going to be a U? Is it going to be a V? What's it going to be? What's the basic shape? U. Okay? So, my shape is a U. Why is it a U? Because it's a square. Why is it going to go up instead of opening down? Because this is positive. Okay? Where am I going to start at? What point? 0, 0, right? Why 0, 0? Because I'm not moving it up or down any. I'm not moving it left or right. What about the 16? What do we do with that? That's going to be 16 over 1. So that's going to be up 16 and over what? 1. So my graph is going to be very, very narrow. It's going to be very, very close together. It's going to look like that. But you can finish it. I'm not finishing it for you, but you have everything that you need to work that one out. On your final, there might be a 2 inside. Like your practice final, I think, had a 2. It might be a 3, but it'll be some number. You're going to have to remember to square it. And then what I want to see is this over here, so you know that it's going to be a very, very narrow graph. Yep. What I'm going to be looking for on the test is the graph. Yes, but it's not going to be this exactly, but you get the idea. I want to see that you're going to start at 0, 0. Okay? And it's going to be very narrow and go up like this. Okay, it's going to look like that. Why is it going to look very similar to this? Because what is the number in front? 16. So you're going to have to go up 16 and over what? 1. And if it doesn't fit on the paper, you can add more to it if you need to, or change the axis. But it's going to be way up there. It's going to be very, very narrow, right? Very, very tight together. So what I'm looking for is I'm looking for something that looks similar to this. So what are some key things? Make sure it starts at 0, 0. Make sure it's going up and not down. Make sure it looks like this and not a V or an S or anything else. So I'm going to look for the shape, where it starts at, and make sure it's really close together. Not way spread out, close together. $35. So you can finish this one on your own, right? I did most of it for you. We talked about it, but you still need to finish it. Right? You still need to put your points in and go from there. 35. I picked 35, and I'm going to have to work 35 out completely just to make sure we understand where all the pieces go and what they are. And I want to make sure we don't make a mistake. This is one of the easiest questions on your final. But it is making sure that you understand the concepts. I want to write this in the center radius form. So what is the center radius form of a circle? Let's write up our formula. Okay, we've talked about it many times. You're correct. It's x plus h, quantity squared, y plus k, quantity squared, equals r squared, right? And what is your center? Center is minus h minus k, and your radius is r. Where do students make a mistake? They forget to change the sign. That is the most commonly made mistake. When you write it, someone will forget to change the sign of that 7. Guarantee it. I don't want you to make that mistake and only get half credit. I want you to do well. Sure. Uh-huh. Uh-huh. It's the same thing. Yep. You always remember, switch the sign in the center. Our textbook does it the other way. They use a minus and a minus here and a plus there. I think this way is easier because you remember, if it's here, you change it. But it's the same. It is exactly the same. Same thing with the slope. You've probably seen other students do it when they talk about the slope. They use y2 minus y1 over x2 minus x1. I use 1 and 2 because we're used to saying 1 and 2. That's just the way I do it because but it's the same thing. It doesn't matter. All you have to remember is switch your signs because you get the same answer. Now, what goes in here? When we bring it down, we have an x plus 0. Quantity squared, which we'll deal with that in a moment. Now, here's where students make a mistake. It is y minus 7. Why is it y minus 7? Because when you go from the center radius form to the center, what do? Switch the signs. So this has to be switched. And what about the other side? It's r squared. What is our r? Square root of 5, and we have to square it. Now, what does that leave you with? That leaves you with x squared plus y minus 7 squared. And what happens when you square a square root? They go away, and that leaves you with a 5. That is it. Now, where do students make the mistake at? Right here. Notice your sign is what? Negative. I don't want you to accidentally forget not to switch your sign. So make sure you remember, switch your sign. Write up your formula, just like I did here. And when you go from the center radius form to the center, or vice versa, you have to switch your signs. I think our textbook says it's x minus h, y minus k, with the center of hk. Same thing as what this is. I just like to write the pluses and then switch the minuses down there. But it's the exact same thing. Is everyone okay with that one? I do not want anyone to miss this question. It is too easy. It's checking concepts. Are there any other questions to look at? Do we need to go through any others? Sure. Why it's do what now? Okay, y minus 7. Now, whenever we go from the center to the center radius form, we switch the sign. Because what we're doing is this. And I'll try to explain it. When we go from the center to the center radius form, we're actually switching the value because what this is y equals 7. Well, if you solve it and you move it over, because we're setting it to 0, you get y minus 7. That's why it's y minus 7 here, and that's why the signs switch. We don't do that, but that's what it is. Okay, that's the reason why we switch the signs. We're switching it around. It's kind of like working with the factors. We switch our signs. Now, we don't have to do this. All you have to do is remember, switch your signs. That's it. Okay, that's all you need to remember is switch your signs. So when it go from the center to the center radius form, what do? Switch the signs. And you don't have to write the 0, okay, because 0 is gone, so it just makes it an x squared. Is everyone okay with that now? So you don't even have to worry about this part, right? All you have to remember is switch your signs. Very, very easy, and don't make a mistake with it.
So let's say y was negative, then it will be positive.
Yep, I can create another one. Let's do another one. Another example. Let's say the center is minus 8, positive 9, with a radius of 3. What would this look like in center radius form? What do? We switch our signs, right? Okay, so that negative 8 becomes a positive 8, and that positive 9 becomes a negative 9, and it's not going to be 3, it's going to be 3 what? Which is then 9. So this would be the answer for this one. That would be the answer for that one. Is everyone okay with that now? There is not much to do with this one, and I want to make sure you get full credit on it. Is everyone okay with that? Are there some others to look at? And we have plenty of time to go through any more of them we need to. Okay, well, do you want me to look at, the other class looked at 30 and 31. You want me to look at 30 and 31? Okay, yep. Now, you don't have to use Gauss-Jordan. You can use Cramer's rule, or you can use elimination on these. I don't care how you solve them, just as long as you solve them. Let's look at 30. The easiest method is going to be elimination. But I don't care which method you use. No, it says elimination, but I don't care which method you use on these. On your final, you're going to have, there's 3 of them, you probably have two of them. I don't think you'll get all 3. When I made it up, remember, I cut it down to 30 questions instead of 40, but there's 3 of them here. They're all going to come out to be solutions. Okay. Now, I don't care which way it says. It says use elimination, but if you want to use Cramer's rule, that's okay. If you want to use Gauss-Jordan, that's fine too. I think elimination is probably the easiest way to do it, unless you're good with Gauss-Jordan. But I would say substitution is the hardest. Cramer's rule is in the middle. So I'm going to use elimination. I think that's the easiest way to do these. If you want to use Gauss-Jordan, you can. But we want to make sure we don't make a mistake on the final. So when we do these, I'm going to use the easiest possible method, which is going to be elimination. Now, I want to eliminate for the x, not the y. Why do I want to eliminate x and not y? Well, when I look at these, 6 and 4, I would have to use a 12, right? Because that's my least common denominator. What about 6 and 3? 6. And so the top row is already done. So let's take the second row and let's multiply it by a -2. And I can work this one with Gauss-Jordan too if you would like, but I'm just going to work this one right now with elimination. If you want Gauss-Jordan, I can do Gauss-Jordan as well. I might do 31 with Gauss-Jordan just to make sure. So that is then 6x minus 6y equals a -12. And when you distribute the -2 through, that's a minus 6x minus 12y equals, let's see, positive 68, isn't it? Yep, make sure you don't make a mistake. 34 times 2, yep, that's a 68. Now when I add them together, what does that give you? The x's, they do what? Okay, and we have a minus 6y, and a minus 12y. That makes it a minus 18y. And when I add down here, I've got 68 minus 12. That makes it a what? 56. We'll divide by our 18. It's a negative 18, by the way. And so now we get y equaling, what, -4, isn't it? Or is it -3? Did I make a mistake? Let's see. Oh. Yep, it's easy to make a mistake. I made a mistake. We saw it. Now, I would have known I made a mistake because when I tried to work this out, I got a fraction. These should all come out to be whole numbers. When I distribute that -2 through, I wasn't careful. -2 times 4, you're correct, should be a what? -8. I was, wasn't careful when I worked it out. And now we've got 6 and 8 makes it a 14. Sorry about that mistake. And 56 divided by 14, that comes out to be a negative what? 4. If you get a decimal, you made a mistake. They are going to be whole numbers on your exam. I will tell you that right now. So if you get a decimal, you made a mistake, start over or try to find your mistake. And it's easy to do that if you get in a hurry. So take your time with these. Now, how do we finish it? I'm not going to finish it, but what would you do? Okay, to finish it, use y equals a -4 in one of the equations. to find x. And what is your answer going to look like? Okay, this is what your answer is going to look like. You're going to have to finish it, but your answer is going to be blank, comma, -4. You're going to have to plug the value in to find it, right? You're going to have to find that value. Is everyone okay with how I did that? Right? I'm not going to finish it because I want you to do it. That way you'll do well in the final. (31), you can use elimination, or you ask about Gauss-Jordan. I can work 31 with 31 using Gauss-Jordan. So let's just try 31 and let's use Gauss-Jordan. Now you can use elimination. And we're actually using Gauss-Jordan with back substitution is what it is. I don't teach complete Gauss-Jordan because it's a lot more work than using back substitution. Now again, I don't care what method you use. The important part is get the correct answer. So any method that you want to use, if you want to use Cramer's rule, which you could do, but I would say use elimination or Gauss-Jordan. These are the two easiest. So what is it going to look like? Well, let's rewrite this. In terms of a matrix, Gauss-Jordan uses a matrix. We have our vertical line there. This is your x, this is your y, and this is the equal sign. So what's going to go here is 1x, because there's no number there, but we know that's a 1, right? We have a 9y, and the other side is a 63. Then we have a -5. We have a 10, and we have a what? 70. Okay, now, which way would be easier to work with? X or Y? Where would we like to make a 0? Yeah, I would probably say make a 0 here. Okay, so we want a 0 there. So what I'm going to do is I'm going to take the top row, and I'm going to multiply it by 5. It's the same thing as elimination. It's just sometimes a little bit easier to keep track of things. But I would take the top row and I would multiply it all by 5. Every single part. 5 times 1 is a 5. 5 times 9, that's a 45. And don't forget, 5 times 63, is that 215 or 315? Let's see. 63 times 5, that's a 315. And we have a -5, a 10, and a 70. Now, what do we want? We want to create a 0 somewhere. We already said we want the 0 here. So what can I do? I can add the top row to the bottom row and place it in the bottom row. So let's add those together and place them in the bottom row. And this is Gauss-Jordan from way back in 5.2. So we're going to keep the top row the same. And add down. Okay, 5 and a -5, adding down, that makes it a 0. 45 and 10 makes it a 55. 315 and 70 makes it 385. Now, what does my equation look like? This is the back substitution part. Okay, what does my equation look like? From here, from this row, it looks like 55y equals what? 385, doesn't it? Right? That's what this is saying here. There's no x's, so it's gone. And that's saying 55y equals 385. And you can finish this by dividing by what? 55. And that gives you y equals now what? Yep, I think it's going to be 7. And it should be a positive 7. Now, how do you find the x again? Yep, you can just use back substitution. You can make a 0 here if you wanted, but that's a lot of work. It would be easier just to use probably back substitution. Take it, plug it back in. So to finish it, what you're going to use is y equals 7 in one of the equations. To find x. And what's your answer going to look like now? Your answer is going to be 7 is the y part, right? X is unknown. Move it up so we can see here. So you're going to have to fill in the answer blank here. Does it make sense how we do it? And I would probably recommend elimination, but you can use Gauss-Jordan if you want. You just asked about Gauss-Jordan, so I said I worked that one out with Gauss-Jordan. Cramer's rule could be done as well. Sure, 28. All right. "28 is a concept question. "28 is just making sure that you understand the basic concepts of parallel and perpendicular lines. It says, write an equation for the line described in the specified form. So in this one, we can only write it in see, this one will be in standard because you can't solve it for y. So we're going to get an answer. Now, what do we know about parallel lines? Parallel lines have the same slope. Okay? Now, this is going to be parallel. And what do we have first off? I'll do this one graphically so you can make sure you completely understand the concept here, because this is nothing but understanding concept. So we've got, on question 28, we've got x equals -6, and we've got the point 3, 5. I'm going to do this one graphically, and we want these to be parallel. I'm going to do this one graphically so you can really understand what's happening. What does x equal -6 look like as a graph? -6 on the x-axis, this is the x-axis, would be back here at 1, 2, 3, 4, 5, 6. It's an x line, right? So it looks like that. Now, think about parallel parking. When we talk about parallel parking and parallel lines, those lines never meet. So what's going to be parallel to a vertical line like this? Another vertical line. Okay? Where's our point at? Well, this is our line here. Where's our point at? 3, 5. Let's find that point 3, 5. Okay, there's our point 3, 5. Now, I want it to never cross the other line. And what's the only way that can happen is that's another vertical line. Right? And vertical lines are x lines. So this one would have the equation x equals what? 3. And that is it. Do you understand what we've got here? So I did it graphically. Or you could just remember that what's parallel to an x line is another x line, right? It's going to be x. Now, if it was y, what would it be? A y line. Now, if it said perpendicular, what would it be? The opposite. If it said perpendicular here, it would be y equals 5. So watch the wording. If it's parallel, parallel means the same. Same slope. Perpendicular means the opposite reciprocal. Negative reciprocal.
So the answer would be 3?
Yes, all I'm looking for here is x equals 3. Make sure it's x equals 3. I did that one graphically. You don't have to do it graphically. The only reason I did it graphically is so you would fully understand what's happening. And that's the only reason why I did it graphically, is so you can understand the concepts. That way you're just not memorizing things. Yeah, if it was perpendicular, it would be y equals 5, wouldn't it? Yep. Does that answer that question? Now, there's going to be one like that on your final. Well, probably. I'm going to take 10 of them off, and I can't remember if I took that one off or not. I think I may have left it on, but I'm not sure. I made the final up a couple weeks ago, but I took the practice one and I took out 10 questions and changed the numbers. Any others to look at? Anything else to look at? Sure. Right, and what I'd recommend on those systems of equations, they should be whole numbers. Now, the others can give you fractions. What I would recommend is that you look at the practice final first. Work it out and make sure you can get the correct answers. Because you've got the practice final in front, and that's got a key with it. So make sure you know how to do all of those. Once you understand how to do all of those and get the correct answers there, then do the take-home final. Okay, they're very, very similar, and you've got that worked out version of it, right, that I showed you how to do step by step. Okay, so that's all you have to do is make sure you know how to do those specific questions. And you'll do great on your final. Students generally do better on the final than any other exam. So make sure you study for it, and you know what's going to be on there. Okay, if we don't have any other questions, then I'll let you out a little bit early. Make sure you sign the sign-in sheet. So here's the sign-in sheet. And I think I've got most of your homework graded. I forgot a couple of you to grade your 5-1 through 5-3 homework. I think I forgot a couple of them, but I'll get them graded. So most of you should have your homework over there. Now, when's the last day that I'll take back homework? Just so we know, our final is when? Our final, again, we meet at 11 normally. So we are going to meet on Thursday, December 15th, next Thursday at what time? 10. Okay, your final's from 10 to noon. When's the last day I'll take any homework? Yep, December 15th when class starts. So anything you're missing, make sure I get it. Look at your Canvas grade book. Make sure I have it all. I'm going to get everything graded later on today and tomorrow. So you'll be able to make sure you have it all before your final.
This is homework.
Okay.
I'm leaving on Tuesday.
Okay. Okay.
When can
So are you going to be here on Tuesday?
No.
I won't be here until next Wednesday. I'll go see if I can find. I'll walk down and see if I can't find somebody to help you. So, okay. Just a second. I'll work with you, and we'll find someone who can proctor your exam. Okay. Thank you. Yeah. Thank you, Edson.
Professor,
Sure.
are you going to be here tomorrow?
I will not be.
Okay, so
Did you want to just turn that in on Thursday?
Struggled with like 2 math, like the number 9 and like these two.
Uh-huh.
So I was thinking of doing it again and doing
Yeah.
it tomorrow.
I won't be here tomorrow, but you can leave it in my mailbox, or you can just give it to me on Thursday when you see me again. Fine. So either
Oh,
way.
I can?
Yep. You just want to wait till Thursday. You can give it to me on Thursday.
So we'll be here on like Tuesday, like next week.
I will be here on Wednesday and Thursday because that's when I'm here for the finals. So I'll be
Then I
here.
guess I'll just submit it.
Do what now?
Can I just submit it?
You can, but why don't you go ahead and look at it and finish the last two,
Okay.
and just bring it on the day of the final. That'll be fine with me. Okay?
we can take Wednesday, right?
Yes. We take our final. Well, let's look at the schedule. Make sure. Okay. Yes, so we don't get mixed up, and I've got a copy for you too. I'll give you an extra copy. Yep, you're welcome. Our class time is normally when? Our class time is